Hey folks, we're going to take a look at some different kinds of defense. We're going to run through this kind of quickly. Essentially, your body has three lines of defense. Okay, we've got non-specific defense, which ends up being our first and second line of defense. Our non-specific defense, what that means is that it's not going to care. Our body doesn't care what it is we're trying to defend against. We're going to defend against anything that will come our way. Okay, this includes skin, mucous membranes, things like that. Okay, so what that's going to do is it's going to keep bacteria and viruses and things like that from entering our body. Okay, the skin's a mechanical barrier, meaning that it's actually like a physical barrier. Okay, it doesn't allow things in. And of course, the mucous membranes are going to trap these little pieces. They're going to trap pathogens and not let them out. Cellular and chemical defense is going to be our second line of defense. These are also non-specific defenses, and that's going to include things like phagocytes, which are going to trap pathogens and engulf them and destroy them. It's also going to include natural killer cells. Okay, and a natural killer cell is going to find a pathogen, and it's going to bind to that pathogen. It's going to release chemicals which are then going to go into the pathogen and destroy it. Okay, so those are all going to be different kinds of non-specific defenses. We also have what's called an inflammatory response, which is triggered by an injury. Okay, and so what's going to happen here is that what's going to happen is it's going to prevent the spread of these pathogens to go to other parts of the body. It's also going to allow for the body to dispose of cell debris and the other pathogens, and it'll start to set the stage for repair. Okay, the four signs of an inflammatory response: you're going to experience redness, heat, swelling, and pain. But if that's happening, that's a good thing, okay? Because you know that your body is doing what it's supposed to do in order to kill the pathogens that have entered your body. Okay, and that's a non-specific kind of defense. Fever is also a non-specific defense. What's actually happening here is that your hypothalamus is resetting your internal temperature. This is going to prohibit the release of iron and zinc, which are things that are needed by bacteria. Okay, and so when that happens, it makes it to where the bacteria can't survive. And so it says it, but it also increases the speed of tissue repair. But if it gets too high, it can mess up your enzymes and your proteins and things like that. That gets us into specific defense. Specific defense are going to be our defenses, which are going to attack specific pathogens in our body. Okay, it's our third line of defense, and essentially what this is it's our immune system. So remember we talked about antigens when we talked about red blood cells and how red blood cells have A antigens and B antigens and Rh antigens. Okay, well pathogens also are going to have specific antigens as well. And what's going to happen with specific defense is that our body is going to recognize antigens which are on pathogens. Okay, before we can do that, we have to have an initial exposure. Okay, that's why when you get chickenpox, you have an initial exposure to that disease, and now your body has a defense mechanism so that the next time it comes into contact with it, it can eradicate it and make sure that you don't get it again. You've got two types of specific defense. You've got humoral defense and cell-mediated. Okay, and the three important aspects of this is that it's antigen specific, meaning that we have to recognize the antigen on the pathogen before we can do this kind of defense. Okay, it's systemic, meaning it's not restricted to the infection site. Okay, it's not like the inflammatory response that we had earlier. It also has a memory, meaning that when we come into contact with this pathogen again, we will be able to protect against it because we're always going to have that response in our body that's going to allow us to not have to deal with that pathogen again. Okay. Let's see here. As far as the cells involved, we have two different kinds. Well, we have lymphocytes. Okay, we have two different kinds of lymphocytes. We have B cells and T cells. The B cells are going to help with humoral defense. Okay, these are going to help us produce antibodies. T cells are going to help us with cell-mediated defense, and they do not produce antibodies. It says both types of lymphocytes originate from red bone marrow. Excuse me. Says what determines if it will be a B or a T cell is where it becomes immunocompetent. Okay, basically where these cells are going to be trained. T cells, they're made in the red bone marrow, but they're going to migrate to the thymus to be trained to do their job. B cells are made in the bone marrow, and they're also going to develop in the bone marrow as well. Okay, they both originate in the bone marrow, but the T cells swim to the thymus to become trained in the defense that they're going to do. Okay. So a macrophage its job is going to be to engulf foreign particles, and it's going to then present the fragments on their surface. Okay. And so what's going to happen then is that a T cell is going to come by and it's going to recognize that antigen, and then it can provide a specific defense to destroy that pathogen. It says, continuing with humoral defense, it says B cells with specific receptors are going to bind to a specific antigen. It says that B cell then will undergo clonal selection. So it's going to make a whole bunch more of itself so that it can then protect against that pathogen later on. It says most of the clones will become plasma cells, which are responsible for producing specific antibodies. Okay, those antibodies are going to be what's going to protect us from it in the future. It says a few will become memory cells, which will become ready to bind with the antigen should it come around again. So then the next time it comes around, those memory cells are going to bind to it and destroy it. Continuing on with humoral defense, this is just a little word about what antibodies are. These are those markers that are on the surface of the pathogen. It says when antibodies attach to antigen, it can have different effects. First off, we have complement fixation. This is where essentially you're going to have um, a one of your body cells which are going to poke holes on the surface of the pathogen, and then that's going to result in cell lysis. Okay, so the cell's actually going to burst. The pathogen's going to burst, which is cell lysis. We also have what's called neutralization. Neutralization is where you have all of these antibodies which are going to attach themselves to the pathogen, and then it's going to basically render the pathogen useless. Okay, it's going to mask the pathogen to where it can't even do anything anymore because now it's covered in antibodies. Lastly, we have agglutination. Agglutination is clumping. This is very similar to what happens when you have two different blood types which mix together. They're going to clump, and then that's going to allow macrophages to come in and engulf them and destroy them. Cell-mediated defense, it says this begins with the macrophages, which destroy the antigen. Uh, the uh, the macrophage then is going to put the antigens on its surface so that T cells can come by and recognize the antigen and then bind with the antigen. It says after binding, T cell clones form, but different classes of cells are produced. We've got cytotoxic T cells, which are also known as killer cells. These are going to be specific in killing virus cells, cancer cells, things like that. Okay, and what they're going to do is it's similar to natural killer cells. Okay, so what they're going to do is they're going to insert chemicals, and when they insert those chemicals, it's going to cause the cell to be destroyed. We also have helper T cells. These are going to encourage the cloning of B cells. It's going to also stimulate cytotoxic T cells to grow and divide. And these are also going to enhance the eating capabilities of macrophages. And lastly, we have suppressor T cells. Okay, suppressor T cells are going to stop the immune response once the antigen's been destroyed. Okay, that's the only way that your body knows to stop the immune response. Okay, is when the suppressor T cell is released. Okay, and that is it. That's our first, second, and third line of defenses. Remember, the first and second line were our specific defenses. The third line, or first and second, are non-specific defenses, like the skin and other non-specialized cells, which just go in and destroy pathogens, and then specific defense is all antibody related, okay, or antigen related. Okay, it's based on the antigens which are present on the pathogen. Thanks, folks.
Okay, guys, in this part of the video, I'm just going to kind of go over exactly what Mr. Coder just taught you, but with an animation. Here we're looking at a macrophage. And if you watch, the macrophages is part of the non-specific defense. And it constantly is looking for things that don't belong. And if you look here, this is a pathogen. It could be a bacteria, it could be a virus, it could be a fungus, whatever. It doesn't belong. And so macrophages are phagocytes. They eat it. Did you see that? It ate that bug, that pathogen, right? And the cool thing about macrophages is that they eat the pathogen, and then they display part of that bug, that pathogen, on the surface of its cell. Remember those things that they display on the surface of the cell, those are called antigens. And now this macrophage, although it's part of the non-specific defense, because it will engulf anything that doesn't belong, it's going to help out that specific defense because it's displaying part of that bug, part of that pathogen on the surface of a cell. So watch what happens. The cytotoxic T cells, there's just another little helper cells, they come and they read the macrophage and they're like, oh look, that pathogen is in our body. That's not good. And so the helper T cell releases some chemicals. You don't really need to know the names of those chemicals, but it releases some chemicals called interleukins. And the interleukins stimulate B cells and T cells to reproduce. And if you remember, the B cells are part of the humoral defense and T cells are part of the cell-mediated defense. And so let's first talk about cell-mediated defense. What happens there is now that it knows, because of that helper T cell told it, it now knows that that pathogen is in our body. So that cytotoxic T cells go around and they look for that bug. They look for cells that have been infected with that pathogen, and it goes around and looks for those cells and it destroys them. Remember, T cells, cytotoxic T cells, grab onto those cells and they just send off chemicals, and those chemicals destroy the infected cells. Okay? So that's one way, one specific type of defense in which these cytotoxic T cells kill the pathogen. The other way is called humoral defense, and this is where the B cells get activated, and they are looking for that one type of pathogen, and those B cells reproduce and reproduce and reproduce and reproduce and reproduce. Okay, and those reproduction of the B cells are called plasma cells. And if you remember, B cells make antibodies. So the more B cells we have, the more antibodies we have, and so they shoot off all these antibodies in the plasma. And those antibodies do lots of different things. If you remember back to our notes, the antibodies do complement fixation. They could neutralize the cells. They can be neutralized. The cells that are attacked by the pathogen, they can be neutralized by the antibodies, or the antibodies can clump it all up and make it no longer dangerous. Okay, but either way, the B cells make those antibodies, and the antibodies go around and kill that pathogen. So both the T cells and the B cells are specifically aiming to kill that pathogen. Okay, now the last little piece of this is that not only do B cells make plasma cells, they also make memory cells, and these memory cells are pretty awesome because they stay around in your body for about 10 to 50 years, I mean decades. And so if you were ever exposed to that pathogen again, you've got these memory B cells to get to work immediately. They don't have to have the macrophage and the helper T cell and that whole first part of the non-specific defense. The memory B cells already know what to do, so they can go and start fighting the bug immediately. Okay, hopefully that clarified some of the stuff about non-specific and specific defenses and how they work together.